morning. So we are going to solve some systems of linear equations by the substitution method. So there's basically 4 steps to the substitution method. The first step is that you're going to solve one of the equations for one of its variables, which will usually be x or y. After that, you're going to substitute the expression that you just got from step 1 into the other equation, and then you will be left with one variable and you will solve for that variable. Step 3, you will then substitute the value that you just got from step 2 into the revised equation from step 1, and you will solve for the other variable. Finally, you will write your solution as an ordered pair, and then you can check in both original equations to see that it is indeed correct. There's a couple tips. So when we're solving a linear system, you have basically 2 equations, most likely with 2 variables each. So you can solve for either the x or the y in the first equation here, or you could solve for the x or y in the second equation to do that first step. Now, a little trick here is that if you have the option, you don't want to choose the x or the y that has one of these 2's as a coefficient, because you'll have to divide everything by 2, which could give you fractions, and then you'll have to work with fractions. It'll just make things more difficult. So whenever you have the option, you want to choose the variables that do not have a coefficient. So you could either do the y in equation 1 or the x in equation 2, and that would make it a little bit simpler. Since we're typically used to getting a y by itself, I'm going to go ahead and use equation 1, and that's what I'm going to use to do my step 1. So step 1, I'm going to start out with equation 1, and I'm going to get this y by itself. And as you might remember, to get the y by itself, first thing you would do is either add or subtract the x term to the other side. So since this is a positive 2x, we're going to subtract it from both sides. And then now we're left with y equals negative 2x plus 1 as our variable expression there. So, all right, so step 2. So now, since we already used equation 1 for step 1, for step 2, we're going to use the one we didn't use yet, which in this case is equation 2. So x plus 2y equals 5. And what we're going to do is, since we know that y now equals negative 2x plus 1, we're going to substitute that in to the y in the second equation. So if we know that y is exactly the same or equal to negative 2x plus 1, in this equation over here, I can just replace or substitute my y with that expression, negative 2x plus 1. Now, when I do that, I now have an equation with only one variable in it, just an x variable. So now I can actually solve and get a value for that x, which is what I'm going to do now. So using your normal strategies for solving an equation, like distributing to get rid of our parentheses, we would have negative 4x plus 2. Then we would want to combine our like terms. So this is really a 1x here. So 1 minus 4 would give me negative 3x plus 2 equals 5. And then, of course, finishing it out, we want to get that x all by itself. And we're going to do that by dividing by that coefficient of negative 3. And we're going to have x equals negative 1 for the value of x. So now we still need to solve for the y. The whole point of a linear system is that you're solving for both the x and the y. So at this point, we would now want to take the value that we just got in step 2, and we would want to substitute it in to that revised equation that we had come up with in step number 1. And that will help us find the other variable that we still have left to find, which is y. So since y equals negative 2x plus 1, and we're going to substitute in this x here in place of the x, we're going to put that negative 1. Now we can just finish solving this for y. Negative 2 times negative 1 is positive 2. 2 plus 1 is 3. So then we get the remaining value. And then, of course, finally, you want to write this down as your ordered pair, obviously in x, y ordered pair. So we know the x is -1, and we found a y, which was +3, so that should be our solution. Now, the one way to check that would be plug these values into the two original equations and make sure that they give you true statements. So if I put it into the first one, I would have 2 times -1 plus 3, which is -2 plus 3, which does equal 1. And then if I plug it into the second equation, I would have -1 plus 2 times 3, -1 plus 6, which does equal 5. So that just confirms that this is the correct answer. Our solution to this system is the ordered pair -1, 3. Now, if you graphed these two equations like we had done in the previous lesson, these two equations would intersect at the point -1, 3. All right, so let's do another example. Okay, so now this time in the first equation, we have an x and a y, but they both have coefficients other than 1. So we have a 2 as our coefficient on the x and a 5 as our coefficient on the y. So if we were going to get either of those by themselves, we would have to divide the entire equation by either 2 or 5, which could potentially give us a fraction. On the second equation, the y has a coefficient of -4, again, would force us to divide, possibly getting a fraction. But we do have this 1x that does not have a coefficient other than 1. So that's going to be my choice to get by itself. So to do step 1 for the substitution method, I'm going to use equation 2. And I'm going to get my x by itself. So first thing I'm going to do is move the other variable to the other side just by adding or subtracting that term. So I'm going to add 4y to both sides. That way my x is now all by itself. And on the other side, the equal sign, I have 9 plus 4y, or 4y plus 9. So now to do step 2, I'm going to use the other equation that we didn't use yet, which is equation 1 in this particular situation. And of course, I'm going to take this expression that I have here that's equal to x, and I'm going to substitute it into my other equation in place of that x. So this 4y plus 9 is going to go in here where the x is. Make sure you're using parentheses when you substitute that expression in because you will have to distribute that too. So 4y plus 9, and I still have the rest of my equation, plus 5y equals 5. So like I mentioned, now we're going to solve for this one remaining variable of y. So we want to distribute to get rid of our parentheses. That will give us 8y plus 18. And we still have this plus 5y equals 5. Combining our two like terms here, we have two y terms, so we can add those together, giving me 13y plus 18 equals 5. Now we want to continue to get this y by itself. So subtracting the 18, 13y equals -13. And then we just have to get the y all alone by dividing this 13, and we get y equals -1. So my third and final step will then be to take this value that I just got in step 2, which is y equals -1, and substitute it into that revised equation I had in step 1. So now I will have x equals 4, and instead of that y, I'm going to substitute in the -1 plus 9. Then just solve it. 4 times -1, -4 plus 9, and I end up with 5. So finally, I can write my solution as an ordered pair. My x is 5, and my y is -1. And then, of course, it makes sense to always check this answer because if you made a mistake somewhere, then you'll know when it doesn't work out. So if I put in the 5 for the 2, or I'm sorry, 5 for the x, plus -1 for my y there, I end up with 10 minus 5, which does equal 5. So that checks out. Now when I go to do the second equation, I'm putting in my 5 for the x minus 4 times -1. So that ends up with 5, let's see, plus 4, which does equal 9. So that checks out as well. So while it is kind of a long process, the steps are on the longer side. It's the same thing after that. So you don't have to worry about all these little tricks and trades and whatnot. At least at this point, as long as you have one of your variables without a coefficient other than 1, it doesn't get too much harder. Now, if we have 4 different variables, or I mean 4 different coefficients there other than 1, then it'll get a little bit more tricky, but for now. Okay, so again, I'm going to use this first equation since that was the only one that had a variable without a coefficient other than 1. Oops. Okay, so we're going to get this x by itself since that was the only variable that had a coefficient of 1. So we're going to move our 3y to the other side just by subtracting it. So now we know x equals -3y minus 10. So now I want to take this expression, -3y minus 10, and I'm going to plug it into the other equation in place of the x. And the reason why I'm putting it in place of the x is because that is the variable that I had gotten by itself. So since x was by itself, I know that x is the same thing as -3y minus 10. So any place I have an x, I could just replace it or substitute it with the -3y minus 10. So just make sure you use parentheses when you do that substitution. And now we're going to solve for the remaining variable, which is just the y. So we have -21y minus 70. -21 and -5y are like terms, giving us -26y when we combine them. And now we're just going to continue trying to get that y by itself. So bringing that 70 to the other side. -26y equals 104. Dividing by that -26 to get y completely alone, and we get y equals -4. And to do our third step, we're going to take the value that we got in step 2, so the answer basically for step 2, which was -4, and we're going to substitute it into that revised equation that we had in step 1. So x equals -3y, which is now going to be -4, minus 10. Multiplying -3 and -4 gives me a positive 12. 12 minus 10 equals 2. So now I can finally write my solution, which is my x, y ordered pair. My x value was +2. My y value was -4. And of course, it's always a good idea to go back and check that ordered pair into your original equations to make sure that it does work. So for the first one, I would have 2 plus 3 times -4. 3 times -4 would be -12, and 2 plus -12 is -10. So that works. On the second equation, 7 times 2 minus 5 times -4 is 14 plus 20, and 14 plus 20 does equal 34. You can even use a calculator to check those. It's not necessary for you to show all the work, but it is important that you check it. Okay, so number 2 this time, once again, we only have one variable that does not have a coefficient other than 1. So for this one, we don't have to worry too much about choosing what to get by itself. So I'm going to use this equation here to do step 1, since that's the only one that has a coefficient of 1. When I go to get this y by itself, we're going to subtract the 5x to the other side. Now, just be careful. You still have a negative in front of that y that can't just magically disappear. It has to stay with the y, which just means we're not finished yet. We have to get the y completely alone. It needs to get rid of this negative. This negative is really a -1, so we're now going to divide everything by -1. This means all our signs will change. We have y equals 5x plus 21. So now, since we used our second equation for step 1, for step 2, I'm going to use my first equation. And I'm going to substitute in the y. So this 5x plus 21 expression is going to be substituted in for y this time, because that's what we had found by itself. So 8x plus 5, make sure you use parentheses when you substitute in the expression 5x plus 21. And now you want to go ahead and solve for your x. So of course we want to get rid of our parentheses first. It gives us 25x plus 105. Combine your like terms. 33x plus 105 equals 6. Subtract 105. Which gives us -99. And then we're going to finish it up by dividing by the 33, which is -3. All right, then finally, we're going to take our value that we just got in step 2, and we're going to substitute it into that original revised equation from step number 1. So y equals 5x, which is now going to be -3, plus 21. -15 plus 21 equals 6. And then finally, we can write our solution as an ordered pair with the x first and the y second, as always, -3 and +6. And of course, once again, you should always check those, but just in order to save some time, I'm not going to keep checking them on this video. Okay, so moving on to number 3. So if I had to ask you which of those 4 variables would you think would be the easiest to get by itself, hopefully you would say the x in the second equation, because it does not have a coefficient other than 1. So our first step here is going to be to get that x value by itself. And we're going to do that by just moving the 4y over to the other side by adding it, since it was a negative. And that gives us x equals 4y minus 2. So of course, since we used the second equation to get the x by itself, we're going to use the first equation, the one that we did not use yet, as the one that we're going to substitute into. We're going to substitute the expression that was equal to x, 4y minus 2, and we're going to substitute that in for x. So instead of writing 6x, we're going to do 6 parentheses 4y minus 2, because 4y minus 2 is equal to x. And then finish up your equation. And now you solve for that remaining variable, which of course there's only y's left in here, so we can solve for y. Distribute to get rid of your parentheses. 24y minus 12 minus 7y equals 22. Combine your like terms. 24 minus 7 is 17. Whoops. Minus 12 equals 22. Getting that y by itself, so we're going to add the 12 to the other side. And then finally, we're going to divide both sides by that 17. And that's going to give us y equals 2. Okay, and then as always, you take the value that you get for step 2, substitute it into that revised equation from step 1, and that will help you find the other variable that you still need to find. So if x equals 4y minus 2, and we just found out that y is 2, we can substitute it in and then simplify and find out that x is equal to 6. And then finally, we can write our solution as an xy ordered pair, which would be positive 6 and positive 2. All right, so practice makes perfect with these. So our next example, this time we're back to getting a y by itself, because this time you'll notice that that is the only variable we have here with a 1 as its coefficient. So that will be our easiest option to get by itself. So in order to get the y by itself, I'm subtracting 6x. Y equals negative 6x plus 26. So now I'm going to use the other equation for step 2. So I'm going to take my negative 6x plus 26, and I'm going to substitute that in for the y. So we got y by itself, so we know y is really equal to negative 6x plus 26. So I can replace my y in the other equation with that expression, negative 6x plus 26. Now, because I only have one variable in my equation, just x's, I can solve for x. Now be careful when you distribute here, because this 2 has a negative in front, so you're actually distributing the negative 2. Negative 2 times negative 6 would be positive 12x. Negative 2 times 26 would be negative 52. Combining your like terms, 17x. Now we're adding the 52. And let's see. 17x equals 51. And then when we divide, we get x equals 3. And then, same as always, you take that answer from step number 2, substitute it into that revised equation from step number 1. So y equals negative 6 times x, which is going to be 3, plus 26. Negative 6 times 3 is negative 18. When we add that to 26, we get positive 8. And that would make my solution here positive 3, positive 8. That would be my xy ordered pair for this particular problem. Okay. Let's see, I think we have a couple more. So hopefully by now you're getting the hang of how to do these. Okay, so number 5, again, we have one nice little variable there with just the 1 for its coefficient. So we want to start with that one. X plus 3y equals 11. So we're going to get that by itself by moving the 3y to the other side by just doing subtraction in this situation. Negative 3y plus 11. So now I'm going to use the other equation for step 2. That would be my 5x plus 6y equals 1. And of course, this expression that we got for x is going to go in for this x here. So we're going to take this negative 3y plus 11, and we're going to put it in for our x next to this 5. Make sure you use those parentheses. Very important. Now we're going to multiply 5 times negative 3, negative 15y, 5 times 11, 55, plus 6y equals 1. Combine your like terms, you're going to get negative 9y plus 55 equals 1. Subtract your 55. Negative 9y equals negative 54. And then when we divide to get the y completely alone, y equals 6. Taking our answer that we just got, that value we got in step 2, substituting it into that revised equation from step 1. So x equals negative 3y, but we're going to replace our y with the 6 that we just got, plus 11. Negative 3 times 6 is negative 18, plus 11 is negative 7, making my solution negative 7, comma 6, the x first and the y second. Of course, you should still be checking these answers by plugging in your x and your y into your original equations. Okay, so now we get to this crazy looking one here because we have fractions in there. Okay, so a couple options. Now, we do see that there is a y by itself here. So I'm still going to kind of go about doing this how I normally would. So if I take this first equation and I want to get this y by itself, don't panic too much about the fractions. All right, since this y is already by itself because it doesn't have a coefficient other than 1, I can move over the 3/2 x. Now, if I move that over, I'm going to have a fraction in my problem. So one option for getting rid of fractions, if this is going to look a little confusing for you and then you're going to have to work with a fraction, is you could come up with something that you can multiply your whole thing by, and then that way you won't have any fractions. So whatever that bottom number is, if I want to multiply this entire thing by, let's say, a 2, I could do that. That will get rid of my fraction here. It will make this y a 2y, and then I'll have a 16. But then I'm going to divide everything by 3, and I'm still going to end up with a fraction in there. So, you know, there's pros and cons to that, I guess. All right, so let's just work with the fractions so you guys can kind of get the hang of if that happens. All right, so when I get my y by itself, oops, so we have 3/2 x plus y equals 8. We're going to subtract 3/2 x. So we have y equals negative 3/2 x plus 8. So now I'm going to go to step 2 and I'm going to have to substitute that in for the y, right? So this thing here, this negative 3/2 x plus 8 is going to go in for that y. Okay, it's okay, don't panic yet, right? So now we're going to distribute though. So we're going to distribute, but make sure you're distributing this negative 1/2. Whenever the number in front of the parentheses has a minus in front of it, that means you have to distribute it as a negative. So negative 1/2 times negative 3/2. Well, negative times negative will be a positive. And if you remember multiplying fractions, you do the numbers on the top, so 1 times 3, the numbers on the bottom, 2 times 2. And there was an x there. Okay. Then we're going to do it times the 8. So negative times positive is going to be negative, but 1 times 8 is 8, 2 times 1 is 2, or you could just think to yourself, half of 8 is just 4. Okay, so now these two we have to combine like terms. This is really a 4 over 1 there, right? So remember when you add up fractions, if I make this a 4, this becomes a 16. 16, 17, 18, 19 fourths x. And then this 4 is going to add to the other side. So then that gives me 19. So to get rid of the 19 fourths, you would want to multiply by 4 over 19. That would leave you with an x by itself, and on this side, the 19s cancel, and you just get 4. So it all worked itself out in the end. So then, now we take that answer from step 2, plug it into our revised equation from step 1. Back in business here. So negative 3 over 2x, and my x is 4, plus 8. Remember your order of operations, you're going to multiply negative 3 over 2 times 4 first, right? So if you're not good at doing that in your head, just imagine this 4 is really over a 1. So this would be negative 12 over 2. And negative 12 over 2 would simplify to negative 6. And now we can add that 8, and we would get 2. And then, of course, our solution here would be 4, 2. All right, so you can still do it with fractions, just makes it a little bit more challenging. All right, and then finally, the whole purpose of doing these kinds of problems is so that we can kind of make some decisions. So it really helps us in decision making when you have two different variables. So this happens frequently when you're making a choice between maybe two different businesses and each one's offering you a little bit different of a situation. So for example, like if I want to get some trees cut in my backyard, maybe there's one company that's going to say, we're just going to charge you $2,000 for the entire day and cut down as many trees as we can get finished in the day. Another company is maybe going to charge me per tree. So it really would depend, like, well, how many trees am I going to cut down? How many hours is it going to take? There's two variables. So when there's two variables, you kind of have to weigh out your options. And so when we use systems of equations, we find out what's the one solution where the two options kind of are equal. So if in the tree situation I was just mentioning, maybe how many trees would I need to cut down in how many hours, like in 8 hours, let's just say, because maybe a full day is 8 hours. What would make it, the same? Because then if I have more than that many trees, then I might want to go for the guy that's just going to charge me like for the whole day, one price. But if I only had like 2 or 3 trees, then maybe it wouldn't make sense for me to do that. And I could just pay per tree, let's say. So, and I'm just using an example because that's something I was actually discussing with my husband this week. So these kind of problems, you can kind of figure out what would be a good decision. But again, the final answer, which studio is the better deal for this problem, is really going to depend on the circumstances, right? And everyone's circumstances are different. So what might be the best for you is not necessarily the best for someone else. So this just helps us weigh our options. So suppose you and your friends form a band and you want to record a demo. Studio A rents for $100 plus $50 an hour. Studio B rents for a $200 fee plus $25 per hour. Okay. So when this happens, basically say to yourself, okay, Studio A is $100 plus $50 per hour, right? Studio B was $200 up front plus $25 per hour. So when we write this into equations, we want to use y equals mx plus b. So Studio A equals 100 plus, and then we can make the hours be x. Okay, so we're going to say, all right, x is going to represent the hours, and y is going to represent the total cost. All right, so let's do the same type of thing for Studio B now. So the total cost of Studio B will equal the $200 you pay up front plus 25 times X, or $25 per hour. Now, at this point, you have two different options on how you could solve this. Earlier in the week, we did solving the system by graphing. So we could graph these two and see where they cross. The only downside is when you're graphing and you have really large numbers like 100 or 200, you're going to probably have to do your boxes by like 5s or 10s or some other increment. And then when they cross, it's really, really hard to tell exactly at what point that was because your boxes are maybe representing like 10 at a time or something. So it's not really a great idea to graph these to get your solution unless the numbers are small. So instead, we can just use our substitution method that we've been working on. Now, the cool thing about this is the first step in substitution is already done for us because the first step, right, is to get one of your variables by itself. Well, we already have both variables by itself, so just pick one of your equations, right? So I'm going to say, okay, I already have this equation, y by itself. So for step 2, I would just have to substitute this piece here into the y in the other equation right here. So in this type of problem, it works out really nicely because basically what's going to happen is since both 100 plus 50x equals y and 200 plus 25x equals y, you're basically just going to set them equal to each other. And you're just saying, when are these two studios going to cost me the same? So studio A, 100 plus 50 an hour. Studio B, 200 plus 25 an hour. So at how many hours will these cost me the same? That's what we're really finding. So we want to get all our x's on one side of the equation. I'm going to subtract the 25 so it doesn't give me a negative. So now that's 25x over here. And then I'm going to subtract the 100. So now I have this. And then I'm going to divide by 25, and that's going to give me x equals 4. And remember, this is representing hours. X was hours. So this means that when the hours are 4, the two studios cost the same. So at 4 hours, both cost how much money? So this is where you would put that 4 in and check. So if I put 4 in up here, right, 100 plus 50 times 4, 50 times 4 is 200 plus 100 is 300. What if you wanted to put it in over here? 200 plus 25 times 4, 200 plus 100 is still 300. So if you record for 4 hours, it doesn't matter if you go to Studio A or Studio B, they're both going to cost 300. So that's what the solution is. If you found the solution as like a pair of an ordered pair in your graph, a point of intersection, whatever, this just means that at 4 hours, both are going to cost you 300. So that information there, that solution helps you determine what studio you want to go to because only you will know, are you going to record more than 4 hours? Most likely, are you going to record less than 4 hours? Maybe you're like, I'm just going to go in there, go for an hour, and then I'm done because after an hour, I'm just too fried, forget it. Then you're going to want to go for the one that costs less money up front, but more hourly if you're going to go 1 or 2 or 3 hours. If you're going to go 4 hours, doesn't matter which one you go, they're going to cost you exactly the same. But if you're going to like spend a whole day recording, then you're probably going to want to go for the one that was $200 up front and only $25 an hour because in the long run, that's going to cost you less. All right, so let's try another one of these options. All right, back in the olden days when I was a kid, we had music clubs, and you would subscribe to a music club and you would pay a membership and then you would get cheaper rates. It's kind of like if you did like Audible, for example, like I might pay 16 bucks a month to have an Audible subscription on my phone or some kind of like maybe, I don't know, music subscription. But if you want to purchase albums to keep and download, and then if you like end your subscription, you still have them, maybe they're like a cheaper price. Okay, same idea. So the first club has a $30 membership fee, and then they charge you $8 per album, which is pretty cheap. And then Club B has a more expensive membership fee, but they charge you less per album. So my guess is that the one that's cheaper per album, if you like to really purchase albums and keep them and download them, let's say, you might want to spring for the higher membership fee because you're going to get it cheaper per album for the downloads. Or if I was doing Audible, let's say the books that I'm purchasing is maybe I like to keep them and reread them or whatever, it would be cheaper. But if you kind of like don't spend most of the time, you just listen to what's available and you don't really download too much or whatever, then maybe you're like, oh, I want the cheaper fee because I'm just going to use mostly just the free stuff anyway. included stuff. All right, so Club A, you start out by paying $30 plus $8 per extra CD, but you could say album, whatever, because we don't have CDs anymore. And then the other option was you pay the $45 up front, and then it was $7 per album that you wanted to keep. So again, oops, I forgot my y equals on this one. Okay, the first thing we always want to do is get a y by itself. But luckily for us, when we set these problems up, both of the y's are already by themselves. So step one is completely done for us. Then step two, we're taking this 30 plus 8x and we're just plugging it in for that y. So then we have 30 plus 8x on one side of the equal sign and 45 plus 7x on the other side. Now we just solve for x. So bringing all my x's to one side of my equation, 30 plus x equals 45. Bringing my constant to the other side, so subtracting 30, and I get x equals 15, and that would be 15 albums or CDs or whatever. So basically, what does that mean? Well, let's plug that number back in, right? So if I try to put it in, 45 plus 7 times 15, what is that costing me? So 7 times 15 is 105 plus the 45 would be 150. And same thing over here. If I did 30 plus 8 times 15, 8 times 15 is 120 plus 30, we get 150. So that means if you get 15 albums, both clubs would cost you 150 if that's for the year. So usually the membership fee would be like for the whole year. So in 1 year's time, if you're going to buy more than 15 albums, you're probably going to want to go for the more expensive membership fee because after 15 albums, you're going to be saving $1 every time you purchase one. But if you're the kind of person who doesn't really purchase many albums to keep, then you probably aren't going to want to do that one. You'd probably rather go for the cheaper annual membership fee. And then if you do download one here and there, you pay a little bit more, but you don't do it that much, so it really won't matter. Okay, so again, remember, knowing this stuff is going to save you money. So if you had no idea which one to pick and you just picked the cheaper one up front and then you bought all these albums later, you'd be like wasting money, right? So it's a good idea to be able to have an idea of where that break-even point's going to be. Now, what about choosing a job? Hopefully, everyone's going to have to choose a job at some point. So here we have job A, which is going to offer you an annual salary of $30,000 a year, plus a bonus of 1% of your sales. Job B is an annual salary of $24,000 plus 2% bonus of your sales. So on first glance, most people are like, "Ugh, why would I pick the lesser job, the $24,000? Obviously, I want to pick the 30, right? Because you're going to get more money in your pocket." But are you? If it's a sales job and you're making a commission, which is a percentage of your sales, if you're a really good salesman, you might make a lot of bonus money. So 2% over 1%, if you're getting bigger bonuses, maybe that'll end up being more in the end. So how much do you have to sell to earn the same amount in each job? So let's do job A. Okay, so for job A, I'm going to just say Y equals, job A is $30,000 a year plus 1% of your sales. Now, when you do percentages, you have to make it a decimal, so it's 0.01x. Now for job B, Y equals, this time it's only $24,000 for your base salary, plus this time it's 0.02x because your bonus is 2% of your commission or your sales, which is your commission. So again, we're going to solve this using substitution. Step 1 is basically done for us. It doesn't matter which one you use as your step 1 because they're both already y by themselves. So I'm going to take this 30,000 plus 0.01x, and I'm going to substitute it in for that y on the other equation. So I have 30,000 plus 0.01x on one side of my equals and 24,000 plus 0.02x on the other side of my equal sign. So now I'm going to solve, right? So minus 0.01x minus 24,000. So I'm moving my 24,000 over here on the left, and I move my x on the right. So now I have 6,000 equals 0.01x. Divide by 0.01, and x equals 600,000, and that would be dollars in sales. So what this means is if you have $600,000 in sales, both jobs will pay you the same because 1% of that $600,000 is 6,000. 2% of that 600,000 is 12,000. So what happens when you add both of these, 30,000 plus 6,000 or 24,000 plus 12,000, you would be making $36,000. Okay. So what does that mean? So that means if you take job A and you sell $600,000 worth of material, whatever that is that you're selling, you'll make your $6,000 commission, you'll make $36,000. If you take job B, even though you're only making $24,000 base salary, if you have $600,000 in sales, you're going to make $12,000 of that, and again, you'll still have $36,000 as your total salary. So what does this mean? Well, what's going to matter here is how hard is it going to be for you to sell $600,000 worth of product? Depends what your product is, right? So if you're selling, I don't know, paper clips, you might struggle selling $600,000 worth of paper clips. I don't know. I'm not an office supply salesperson. But what if you're selling, like, I don't know, houses? Do you think you'd be able to sell $600,000 worth of real estate in 1 year? Probably. I mean, you might be able to sell one house for that much. So if you were a real estate agent and this was your salary situation, you might want to choose job B. Even though you're only getting $24,000 up front, chances are you're probably going to exceed $600,000 in sales in the year. But if you're selling a product that's maybe, just new and it's still taking off, or maybe it's just not that expensive of a product, then you might want to take the higher base salary and then not take such a chance on your commission. Another option that people sometimes do is they'll look and see, well, what did the previous person do? So let's say, for example, it says part B. You believe you can sell between 500,000 and 800,000. Which job should you take? And there's really no right answer because 500,000 is a little lower than the 600. So if you only sell 500,000, you do stand to take a little bit of a loss if you choose the higher commission job. 800,000, 700,000, more than that though. So for part B, if I gave you that on a quiz, there would be no right or wrong as long as you could defend your answer and explain why you chose that. All right. So hopefully this helps you kind of see like why we're learning how to do this and how it could come in handy in a situation where you have to kind of make a decision financially. It'll affect you. And that's it. All right. So if you have any questions, you guys know where to find me. And that's it. See you next time.